Hello engineers, welcome back to Civil Nirman. Now if you are here for the first time, I want you to check out our first part first, then start watching over here for the part 2, where we have discussed how you can check the foundation drawings. And here we are with the part 2 of the foundation design drawing checklist. Now till now we have discussed 11 important tips that you need to take care while checking a foundation drawing. Now let's go further with few more important tips related to the foundation drawing checking. So let's get started. So next tip. Now before the next tip, let me just tell you, in the last part we have discussed about the last checklist point that we have checked, that whether the adjacent building and its foundations, if are available in your category of the structure, then if they are shown or not, right? So that was the last tip. Now another one is related to the similar one. Okay, so the tip number 12 is that you need to check that if this particular drawing is separately developed, then the reference drawing number for this particular existing structural foundation should be there as a reference in your drawing, right? So you need to check that particular point too. Next tip, check if the foundation depth varies. In your case, sometimes it happens that we have to provide the foundations at two different levels, right? Let me show you something like this, right? Here, as you can observe, these two foundations are at two different levels, right? So in such scenario, check if the foundation depth varies, then you need to check the excavation line whether it is given or not. Now the next question that comes in your mind, that what is excavation line, right? So just for your information, let me just tell you that in the foundation drawing, the excavation line refers to a specific line or boundary that indicates the extent and shape of the excavation that needs to be carried out to prepare the site for the foundation construction. Now see, it's a critical element of the drawing as it provides a clear reference for the builders and contractors to understand the required dimension and depth of the excavation. Two main purposes: the excavation line outlines the outer boundaries of the foundation and it helps in defining where the foundation will be built, ensuring that the builders dig within the correct area. Now you have clear idea about the excavation line as well. Next step is about the foundation schedule. So in the foundation schedule, what you need to check, so for that particular, let's just take an example of this particular segment where I have a very long structure where we have few foundations and their markings. You can observe the footing numbers and the column numbers, right? And it has some schedule based on this numbering. So for the foundation schedule, what you need to check, so first thing, check foundation marking with the layout. So we need to check the foundation marking with the layout. Second, column size and foundation detail as per the input given. Now see, as an engineer, whatever the input you have provided to your drafting engineer, you must cross validate that particular in your drawing as well, whether it has implemented correctly or not. So here is the first profile that I'm showing you roughly, okay, to give you an idea. So based on this grades and foundation numbers, we have its schedule right over here. So you can observe a table where we have specified the category of the foundation and the total types. Total we have 7 categories of foundation, 7 different sizes, and based on that the table related to the foundation is scheduled over here. So in this particular, you need to check size and foundation details as per the input, grade of concrete as per the design consideration, right? Here it is specified over here. Size, thickness of the PCC, so here the PCC size is also specified and the RCC size is specified. Then foundation bottom from NGL as per the soil report. Now whatever the design depth you have considered based on soil report, that you need to mention clearly in your typical drawing. So you can observe over here the depth of foundation is clearly mentioned with respect to the FGL, that is the finished ground level. Now in case of the natural ground level, you need to check your depth as well related to the NGL or FGL. The way we have the foundation schedule, similarly you need to check the column schedule as well. So here, right here, after the footing schedule, we have the column schedule as well, right? Now for your reference, you can observe over here for the column details, we have specified the column number, concrete grade, its size, main steel and the ring specification as well over here, right? And based on the number of bars, the arrangement is also shown over here. So in column schedule, what you need to check? So column markings with the layout as per the input, right? You need to also check floor wise column schedule table and check column levels as per the architectural drawing, and check the reinforcement change as per the input given if it's there. If you have throughout same reinforcement detailing, then there is no issue. But let's say after few floors, if you have reduce or reduction in steel, then you need to check column size and reinforcement detailing. Also check for stirrup spacing as per the confining and non-confining zone for the columns and pedestal respectively. Okay, also check the typical cross section of the column with the arrangement of vertical reinforcement and ties as per the input. Now this one is the typical table. Now let me just show you another example where we have level wise column detailing. So whatever points what we have discussed, now let's understand this through a sample example. Okay, now to give you an idea, here I'm sharing one reference sketch to all of you to give you an idea how you can provide a typical sketch floor wise for a particular number of different categories of columns. Let's say here we have few categories of column where we have specified the section floor wise, right? So starting, you can observe minimum depth of foundation from NGL, it is specified. Also we have shown the NGL as well. Finished floor level is also specified. You can check out over here the confining and non-confining zone as well as per the ductile detailing, right? So if you have any idea, let me just give you a quick highlight. You can check out this ductile detailing part in IS 13920, where you can check out the detailing portion, how we are detailing the, that means the ordinary detailing versus the ductile detailing, right? So you can refer all these points. Similarly for the column as well, you need to understand how we are detailing column in the ordinary manner, and if we are detailing it with the ductile part, these are the clauses you will find in your IS 13920 2016. Here I have just given you a representation of both the clauses with the comparison, so you can check this out too. I'm not going in much detail over here, but you can refer this clause numbers in the code itself with the sketch. So you need to check all this portion regarding the detailing part in your in the sketch as well, whether it is followed or not. After this, check your table as well. Let's say, let me close this. Let's say for the table part, whatever the column detailings you have provided, right, that table should be there with the label marking as well. So let's say foundation to plinth beam, then plinth to the ground floor slab, and so on, right? So whatever the detailing, you can provide this like in the table format, and based on the number of bars, the typical arrangement has to be shown over here as well. Let's say if we have the different categories of bar, the detailing is shown over here with the stirrups and the arrangement. Also check the confinement zone. Now this particular labels, all these labels should be matched with your architectural drawing as well. Now just to give you a highlight, I have this particular section of that architectural drawing where we have marked all the labels. I need to identify this NGL, FGL and finished floor level or the ground floor slab level to this table, right, whether it is correctly represented over here or not, right? Similarly, in the same manner, you need to cross validate those levels in your typical longitudinal section as well, floor wise column section where you have specified, right? So let's say if we validate FFL is 100.150 and the ground floor is 104.350, right? So if I deduct this, this particular height will be 4.2, which needs to be cross validate over here, plinth to TOC 4.2 meter. And another important point I just want to highlight you over here is regarding the difference between this finished floor level and top of concrete. Now see, it do not necessarily indicate the same height. Okay, they can be at the same height in certain situations, but they often differ. Now let's clarify this with an example. So just to give you a highlight, the similar sample I have over here where it represents the TOC, that is top of concrete, is 5.45, right? FGL is at -1.2 level. If I show you the architect of that particular for the same over here, you can observe here is my FFL. FGL is at -1.2, but if you observe the FFL part, that is at 5.5 meter, right? So the actual height over here is 5.45. That is your TOC. Remember that. That is top of concrete. FFL is your finished floor level. So finished floor level includes your tile thickness, right, that we provide additionally on the top of your concrete. Okay, so also you need to check all these 2 points, how the architect has displayed this particular segment in his drawing and how you want to convey that particular in your structural drawing. So make sure you understand the difference between these two. To give you another idea, let's clarify that particular with an example. Let's say you are designing a ground floor of a building with a concrete slab as the structural foundation. Okay, now the ground floor is going to have rooms with the various types of flooring materials. Okay, it can be wood or regular tile flooring. Okay, so let's say you plan to have finished floor level of 1 meter above the ground level. Now that means that the floor surface of the final flooring material like tiles or wood in the rooms will be positioned at 1 meter above the ground level. Alright, now the concrete slab's top surface, which serves as the foundation for the ground floor, is at an elevation of 0.8 meter above the ground level. Okay, so this is the top of concrete. It's the highest point of concrete slab itself without considering the flooring material. Okay, so in this example the finished floor level is 1 meter above the ground level, you can say that, while the top of concrete is 0.8 meters above the ground level. Therefore they are not at the same height. Now the difference of that 0.2 meter or 20 centimeter accounts for the thickness of the finished flooring material that will be placed on the top of concrete slab. So while the finished floor level and the top of concrete are related, they take into account different aspects of construction and the final floor surface versus the highest point of concrete structure. So that you need to understand clearly. I hope these 2 points you understand this with an example clearly, right? Now let's move on to the next step. So remember that in few of the drawings all the levels are provided with respect to the RL, or you can define your ground floor as 00 and specify the levels with respect to height. So that is the additional point you need to keep in mind as well. Next important tip: check for the hold mark in your drawing, right, if it's not finalized. Now let's take an example. Let's say in case of the anchor bolt details, if it is not finalized, then adequate height of the column casting shall be given with hold. For example, you can provide 1500 mm approximately from the bottom of the base plate. Now see, in some situations, let's say your structure, let's say if you have a warehouse where you have columns at certain height that are in terms of RCC, right, and your roof structure is in terms of steel structure, right? So in this particular scenario, it might happen that you haven't designed your anchor bolt and details yet, right? So in that particular case as well, you need to specify the hold mark in your drawing. So let's understand that point through an example over here. See, let's say for a particular structure I have this corbel and the anchor bolt is not finalized, and if I am releasing that particular drawing, then you need to check the hold mark regarding that particular part as well. Here it's a corbel part, but let's say if your anchor bolts are coming on your column part, right? So in that case, adequate height of column casting shall be given on hold. Okay, and also you can provide the reference drawing number for that anchor bolt drawing or the anchor bolt clash check drawing. So this is one of the important point you need to keep in mind. So from that anchor bolt part, I remember one more important point. Let's say in your structure or industrial warehouse you have RCC column and above that you have steel roof truss. So in such scenario, first of all you need to identify the base plate size, right? And depending upon the base plate size, you can finalize your column RCC column sizes. Because see, for the concrete edge security, you need to provide some edge distance from the anchor bolt, is right? So in such scenario, or let's say if you have a steel structure, so in the steel structure case, once you finalize your foundation design, then after you need to finalize your anchor bolt and base plate as well, right? Because after finalizing the base plate size, depending upon that, with incorporation of the few edge security for the concrete, your pedestal size will be little bit larger compared to your base plate size. So in that case you need to finalize your base plate first, and that point you have to keep in mind. Then final tip related to the typical compaction, right? You need to make sure whether the backfilling is to be done with the existing excavated soil or not. Confirm this with the BOQ, or you can ask your project coordinator if it's not available. And if the backfilling is to be done with the available earth, then remember that the compaction is done in layers not more than 300 mm each to achieve the 95% maximum dry density. Okay, so you need to provide the compaction detail as well, right? Next point, construction joint section and its detail, whether it's provided or not. Now see, in case of the industrial building, where if you have the large concrete area, so in such scenario the construction joint in concrete is used to prevent any cracks. So the construction joint in concrete is used to prevent any crack during its life period. See, concrete has the property of expansion and contraction due to temperature changes, right, which is resulting in the change in the volume of the concrete. So this change in the volume of concrete can be a cause of concrete cracking. Therefore, to prevent the concrete cracks, construction joints are provided in the concrete. Here I am representing a typical sketch just to give you a rough idea about the construction joint detail. See, construction joint is essential if the size or the length of the concrete members exceeds some limit, right? In case generally for the short length concrete members, construction joints are not required, because for the expansion and contraction of concrete, there is the end of the concrete is too close. But when the length of the concrete members has exceeded a certain limit, there is no end point where this volume may change and it may create a crack. Okay, so that's why it's important. Next, detail for the expansion joint. Now see, expansion joints in industrial floor constructions are used to accommodate the thermal expansion and contraction of the materials due to temperature changes. In an industrial setting where temperature variations can be significant, these joints prevents the buildup of internal stresses that could lead to cracks or other structural issues. Expansion joints are typically installed at specific intervals or locations where the floor is likely to expand. These joints allow for the floor to expand without causing damage. Next is contraction joints. Contraction joints, also referred to as control joints. They are essential in industrial floor construction to manage the natural shrinkage of the concrete as it cures. Now, by creating planned cracked At specific intervals, you guide the formation of cracks in a controlled manner, preventing uncontrolled random cracking that might occur otherwise. In an industrial building where large areas of concrete are common, contraction joints are crucial to maintaining the integrity and appearance of the floor. In summary, contraction joints manage the controlled cracking that results from concrete shrinkage during curing. Construction joints are created where two pores of concrete meet, maintaining structural integrity and ensuring proper bonding. And expansion joints account for the thermal expansion and contraction due to temperature changes. So each of these joint types serves a distinct purpose in ensuring the longevity, stability and appearance of the industrial floors by addressing different types of movements and stresses that the floor might experience over time. Alright, so I hope you found this particular video very helpful and you will get a clear idea how you can check your foundation drawing. Now if you found this video helpful, don't forget to hit that thumbs up button and subscribe to our channel for more fundamental conceptual content. Now if you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and I'll see you in the next video. Remember, don't just learn software, learn concepts. Thank you.